I'm ready. Odds first. Any odds? 5 and 7? Free response 1B. Let's start with the practice problem. Sorry, let's just go in categories. It helps my brain. Wait, hold on. Pause. What was this whole packet about? Not just limits. Okay, so pause. You should have done some reviewing on all 3 of those topics last night. True? Okay. Eyes on me. See how well you reviewed all those topics. Limits. One type of limit is a limit. See, get in. Done. But what if you have a piecewise function? Not even check. If it's obviously in one of the pieces. Let's say we have something like this. And let's say whatever number you're supposed to plug in truly is less than a. We could say a is 2, and let's say you're taking the limit at 1. Wouldn't you just plug it into the right piece and be done? Where's the problem? What if you're plugging in the separator? If you're taking toward below and above, what has to be true for any limit to exist? The below and the above must agree. So if you have a piecewise function, and if you take a limit separator, you have to plug in the below and the above and compare. But let's say you have a normal function. You plug it in, you get a number, you're done. Wait a minute. What if x is approaching 2 from below, not a piecewise, but a normal function? Don't we still just try to plug it in? Okay. But let's say you plug it in and something weird happens. What's something weird that could happen when you plug in a value? 0 over 0. If you get 0 over 0, what does that mean? How, though? Maybe factoring, maybe multiplying by the conjugate, maybe simplifying complex fractions. However, at the end of first semester, we figured out there was something called L'Hopital's. And what does shush, Joe and Lorenzo. What does something called L'Hopital's can do? When can we use it? Indeterminate form, specifically 0 over 0, infinity over infinity. There are other indeterminates, but they would need to be rewritten to be 0 over 0 or infinity over infinity, because L'Hopital says if it's a valid L'Hopital's problem, the only way to solve is to take a limit as x approaches c of an f over a g and do what? Derive f prime over g prime, then plug in. How many times can we do L'Hopital's? As many as there are indeterminate forms. So if you start plugging in a L'Hopital's that's still 0 over 0, okay, go again. Still 0 over 0, okay, go again. But let's say you plug in and get number over 0. Ooh, is that a L'Hopital's? No. Because if it's number over 0, zeros in the denominator, aren't those vertical asymptotes? So if zeros in the denominator are vertical asymptotes, and if you're coming in towards a vertical asymptote, what's that limit going to equal? Either positive infinity or negative infinity. Check the sign. Isn't that called infinite form, number over 0? How do we check the sign? What if we're going towards 2 from below? We know it's positive or negative infinity. Check the sign. It's a number over 0. But how do we know which? 2 from below. What can we plug in? 1.9. Check the sign. And if we're doing 2 from above, we can plug in 2.1. Check the sign. But let's say L'Hopital's, we don't get a number over 0. Let's say we get an actual value. Well, aren't we done? Cool. What else can we approach besides x approaching a constant? Infinity. X approaching infinity. X approaching infinity. Wait, you can go to infinity, but can't you also go to negative infinity? What is the big category of what we should be thinking of whenever we see a limit as x approaches infinity? The power, more specifically the degree, because we are supposed to be thinking of degree tests. What happens if the bottom is stronger than the top? 0. What happens if the top is stronger than the bottom? Plus or minus infinity. Check the sign. Imagine plugging in a big positive or a big negative. What would the sign be? What is somebody that we have to watch out for when going to infinity? E to the x, or 2 to the x, or b to the x, because if we have e to the x, or b to the x, or 2 to the x, or 17 to the x, what happens in positive infinity? Will he dominate or will he lose? He'll dominate. But if, well, I should say, it could be e to the negative x, and then everything's, if the exponential has an infinite, a positive infinite power after plugging in, he will dominate. But if the exponential, when plugging in, will have a negative infinity power, he'll go to 0. He's going to lose. The exponential was going to 0. The 0 power, I should say. What if the exponential was going to the 0 power? Anything to the 0 power is 1. Oh, interesting. Was there anything else that we should watch out for? Pause. Square roots we should watch out for. We'll come back to that. I think there's actually a multiple choice that we could look at that has to do with a square root and a limit to infinity. But pause. What do we call the graphical feature if infinity equals a constant? So it's not going up without bound, down without bound. It's actually bounded. Not spirit fingers, but a dotted line. What is that? A horizontal asymptote. Isn't a horizontal asymptote somebody that we can find by limits to infinity and or negative infinity? There can be 1, there can be 2, there can be none. However, can you guys go to FRQ number 2, letter C? FRQ number 2, letter C. There is another type of wording that has to do with limits to infinity. Does anybody find it and think it was a little bit weird? End behavior model. Who the crud is that? Okay. Hold on, I need to get my function too. End behavior. What's going on at the ends? End behavior. What's going on at the ends? End behavior. What's going on at the ends? At the end. What's going on at the end? Oh! If I'm going to the right, that's positive infinity. What's going on at the end? Oh, if I'm going to the right, that's negative, left. That's negative infinity. At the ends, we're talking about limits to infinity. But the end behavior model, if end behavior has to do with going to the right to the left, aka going to infinity and negative infinity. Guys, how would we consider the function going to infinity or negative infinity? What would I have you guys do? As you think about the ends, aka right now we're thinking to the right end, what would I have you look at? The whole thing? What's most important? The highest power. Where's everybody else? Jaden's doing this on his own. The highest power, right? The highest degrees. I never gave you a name for those highest degrees. But guess what the name is? The end behavior model. Whenever I had you guys consider the highest degrees and ignore everyone else, I was actually having you think about a separate function that has a special name, end behavior model, whose end behavior this function will be approaching or will be mimicking eventually. All this plus or minus stuff is going to make it funny in between, but eventually all of this, basically, all of the extra things, as x increases without bound or decreases without bound, these will have negligible effect. Meaning we can just consider the end behavior model. But when I had you guys testing the highest degrees, I had you ignoring everything and just looking at the end behavior model. But guys, what's the limit of this dude? What's the same thing as the limit of this dude? And what's the limit of this dude? Well, if I'm going to... So the same way we would just ignore and take it, we can actually look at the end behavior model and say, oh, hey, the top wins. This is the top wins. Wouldn't this be positive or negative infinity? Check the sign. But if you were just looking at the end behavior model, you could actually cancel out stuff, and you could say, oops, sorry, that shouldn't be a 2. 3 minus 2 is 1. If I'm going to positive infinity, wouldn't this be a positive infinity? And if I'm going to negative infinity, wouldn't this be a negative infinity? So I could talk about the end behavior model and its limits synonymously with the original. So anyway, all that to say, if they asked us, wait a minute, isn't that what part D said? Find the limit? If they asked us to find the limit towards positive infinity, yeah, the top wins, plus or minus infinity, plug in a positive, it's a positive infinity after checking the sign. If we're going to positive infinity. However, if they're asking for the end behavior model, they're just asking for this guy. They're just asking for those highest degrees, which can become x over 3, or it could become x cubed over 3x squared. Either way, it's the end behavior model. It's take the strongest guys from the top and from the bottom. And then in this one, part D, when they say take the limit of the ratio, if you take this guy over his end behavior model, the limit ends up being 1 because their degrees are tied. Anyway, that was a quick little, I know it's an even, but I think the trickiest part of the entire packet was this vocab, end behavior model, that you guys probably hadn't seen before this year. Okay, to the end, we got a pretty good review of limits, except what else is in this packet, guys? Continuity. How does continuity tie in with limits? What are the 3 things that have to be true for a function to be continuous? Number 1. F of c must exist, meaning function must exist at all different possible x values of c. F of c must exist, all points must exist. Number 2, the limit as x approaches c of f of x must exist, so that f of x, as x goes to any c from either side, the limits must agree on an approach. And then number 3, they have to agree. So where the limits say you're headed and where the point actually is, all of it needs to be in line. So the limit from below equals the limit from above equals the point. And definition of derivative, how does that have to do with a, oh wait, what is the definition of the derivative? Slope of the tangent line, no, that's just a description. F prime of x, good, keep going, equals what? F prime of x equals the limit, right? Right? Ah. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h for h equal to delta x. So we could just say x for all that stuff, right? We have alternate form. F prime of a equals, careful, limit as x approaches a, that's one of them, of f of x minus f of a over x minus a. F of x minus, remember, it have to be y's and x's. Delta y's, delta x's. F of x minus f of a all over x minus a. But there's another one. The limit, f prime of a equals the limit as, we already said that. That is when x approaches a. Delta x, or h approaches 0, of h, no, f of a plus h minus f of a all over h. Okay, all that to say, are there things in your, when you see you think, your 27 essentials, your cheater sheets, your forever cards, and your notes that you should have reviewed about limits last night and doing this? Yes, hopefully some of what we just did helps you to that end. Kiddos, what questions do we have, first of all, on the practice problems? Now I'm ready. 7, anything else? 8, anything else? Let's start with 7. What did I tell you just a second ago? You also need to watch out for, wait, in one of our packets, didn't we have a watch out for exponentials going to infinity? The 27 essentials, I think it was. Maybe the cheater chart, or the cheat sheet, I should say. So I think some of you, do you guys have a highlighter out? Do you guys have a colored note-taking pen out? If not, you probably should. If not, you probably should. Because exponentials are not the only guys to watch out for. I said a second ago, there's someone else to watch out for, and the other someone to watch out for are square roots. Kiddos, if you were to try to find the end behavior model of this function, the end behavior model would be all over 2x. What? What? So we square root this? No, we can't square root this guy. That'd be killing a puppy. But we think about the degree and think about what would have a tied degree. Guys, what is the square root of x squared? It's illegal for us to take it, but we're thinking about the degree. Square root of x squared is? No, absolute value of x, which is sometimes opposite and sometimes the same, depending on whether negatives or positives. So if that's true, if I'm going to negative infinity, am I dealing with negatives or positives? Negatives. So it would be this one, the opposite branch one. The opposite branch one, oh, hey, look, it's negative 1/2. The very mathematical way of finding this would be considering the end behavior model and taking that limit. The degree test trick would be, check it. Aren't the degrees tied? Oh, so it's 1/2. No. With square roots especially, just like with e to the check. This one, ratio of leading coefficients, is 1 and 2. But guys, imagine plugging in a negative number. A negative squared, square rooted. Isn't that a positive? Isn't that a negative? What's a positive over a negative? There's a way to use the degree test to get there as well, not just the end behavior model. This guy, the end behavior model, well, he's the same thing as far as considering the degree of the top, degree of the bottom, except he's positive numbers going to positive infinity. So it'd be the positive x for the similar degree and behavior model over 2x. Or you could have also thought of the not as mathy way. Would have been like, hey, aren't degrees tied? Take the ratio of leading coefficients, but check the sign. Isn't that a positive over a positive, which is a positive? Dun, 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 dun. Dun, dun. There are end behavior model ways of doing it, but there are also degree tests. Just check the sign. What should you be writing yourself a note about? Check the sign, but didn't I also say something about what should you watch out for besides exponentials? Square roots. Watch out for square roots. They like to be confusing. All right, any more practice problems before the multiple choice? 15? Why don't you like 15? Because he's a unit circle. Because isn't this just a plug and chug, guys? What's the struggle? I need you to know the square root of 3 over 3, 1 square root of 3. Who is this? The cheater chart for trig. What row am I talking about? The tan row. What are my angles? Well, that's the pi over 6, the pi over 4, and the pi over 3, of course. Where's the 0? Missing. Where's the pi over 2? Missing. Find your sine, find your cosine, and divide. P.S. He's 0 and he's undefined. But anyway, what's tangent of pi over 4? Square root of 3 over 3, 1. Why? Because sine over cosine is root 2 over 2 over root 2 over 2. They reduce to be. What's 1 over anything? The reciprocal. Okay, any more practice problems? Going once, going twice. It's time for multiple choice. Why am I going so fast? Because you guys have time to powwows. You should know your questions just like this. Multiple choice, what do we got? 8? Any odds first? 5? We'll start there. Number 1, I love it. He's a limit. Yeah, but what else is he? A derivative. Read it. Don't you guys, oh, why are you doing this? I don't want to save you. Okay. Please, you're seeing your forever card. Some of you need to highlight on your forever card this dude. Why? If I can find this dude, how do I solve this entire problem? By finding that dude. Meaning, who's f of x in this? Oh, so if sine of x is my f, and if I'm trying to find my f prime, what does this equal? Substitution. Cosine, dun, 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 dun. Some of you need to highlight where the f can be found. Hey, are there any more of these? Number 2. What's different about number 2? It's not an f prime of x, it's an f prime of a. But hold on, pause. Stop stressing. Aw, but I don't have x's. Make an x. Isn't that where the x would go? Oh, cool. All right. Who's your f of x? Who's your f prime of x then? But we didn't have x's. What did we have? Oh, so we're not trying to find f prime of x. We're trying to find f prime of when x is pi over 3. So all we have to do is negative sign of unit circle. Why am I writing 1, 2, 3? Cheater chart, sign, pi over 6, pi over 4, pi over 3, all over 2 with little square roots, except I know the square root of 1 is 1. Pi over 3, isn't that square root of 3 over 2, but with a negative attached? My visual people, pi over 3, it's the bigger slice, and the opposite is tall, square root of 3 over 2, with the negative. Hey, are there any more definition of derivative ones? Yeah, but I can't do them all. Can I have you go look at something way down here? Number 13. Number 13. How many of you guys came in today with some sort of at least kind of question on this one? Yeah. Okay. What happens when you, oh, x is approaching a constant. It's easy. Plug it in, plug it in. Oh. What do you get? P.S. Numbers 1 and 2, didn't you also get 0 over 0 when you plugged in? Keep going. Yeah. You could multiply by the, you guys remember the algebra, the conjugate? You could do that. Period 1, Grace Burgell was like, yeah, it worked. I was like, sweet. You could also do L'Hopital's by taking the derivative of the top, derivative of the bottom, and then trying to plug in. But the reason why I pointed your attention here was not because of showing you a L'Hopital's or multiplying by a conjugate example, but to say he's really just a derivative. Huh? Abby, didn't you say a second ago that there was an alternate form where x was approaching a? Ah, do you guys remember what the formula was? F of x minus f of a all over? Is there another place that you should highlight in your forever cards? Function whose derivative you should take. Who's your f? What are you supposed to be finding? The derivative. You're supposed to be finding him at, whoo! Got him, coach. But do you? Do some of you need to highlight your f of x's and then remember your definition of derivatives because some limits get easier? Now, this one could have been solved many different ways. But numbers 1 and 2, and some of those could only be solved seeing that it was a derivative. Be careful. Okay, I skipped over questions. I know I did. So what else do we have on the multiple choice? 10. We're doing evens. Any more odds on the multiple choice before? I think Lainey, yours was 8, right? No, someone had 8. Abby, you had 8? 8 and 10. Any more odds, real quick, multiple choice? 11. I think we did 5, didn't we? Oh, we didn't do 5. Someone said 5? Okay, we'll do 5 and then 11. Oh, I love number 5. Period 1 wanted number 5. Why do I like it? It's piecewise and it's not this guy. Can we look up to the board real fast? Why do I have this guy on the board? What am I doing if I'm looking below, looking above, and looking at? What am I testing for? If I'm looking below, I'm looking above, and I'm looking at. Definition of continuous. Continue. Oh, and the limit has to, the point has to exist, and all 3 of these must agree. What's different when our piecewise function doesn't have a specific below piece or a specific above piece, and they say find a limit? What's different? What happens if I need to go to -1 from below? For my f of x, who am I plugging into? Where's below? -1.1 is here, right? Isn't it here? Below? Because below's not at. It's not that guy, so it must be that guy. Okay, sweet. So I should be looking at this guy. Hold on, but we also need to go above, right? My distracted one's still focused. If I'm going above, whoever said yeah probably wasn't distracted. Which means good, but the rest of you listen. So if I'm coming towards -1 from above, well, wait a minute. It's not at. Isn't it still that guy? All the belows are here. All the aboves are here. The only thing not here is the at. Oh, so if I'm doing it for both, then can't I just look at that guy? So, the limit, as x approaches -1, says just look at the not equal to. Guys, how do we take this limit? Plug it in, plug it in. That's a 0. I bet it's keep going. Double check, but when you plug into the top, yes, it's 0 over 0. Some of you, your derivatives are better than your factoring. Truth. So, why am I saying that? Could you factor, cancel out, and then plug in? Yes. But what else could you do? L'Hopital's. L'Hopital says take the derivative of the top, derivative of the bottom, and then towards him. 2 times a -1 is -2 minus 3 is a -5. Okay. Number 11. Concept-y one. I see the word continuous, and I see other stuff too. Which of the following is true? Careful, they could be asking false. Sorry, Jack. Can you go hit escape on my keyboard? Gracias, señor. Okay. Which of the following is true about the function if the function is that? Why am I going to start at number 3? The clock's ticking. Why am I starting at number 3? Horizontal asymptote. All I have to do is degree test. Sweet. Degree test. I have a squared and I have a squared. Tie. Ratio of the leading. Not 0. Okay, forget him. Vertical asymptote. Why am I going there next? Look at the denominator. I know some of you, I gave you a little bit of an out, but do you have to factor on the AP test? Could I rewrite this as x minus 2 squared all over x minus 2 and x plus 3? Yes. Is there a vertical asymptote at this guy? Yes. Why would it be wrong if it said 2, even though there's a 2 down there? That's a hole. That's a hole. He is a vertical asymptote, but either way, true. Why am I going to stare at this for 1 hot second and be like, nope, false? It's not continuous. He's a hole. I just said he's a hole. It's a DNE if you plug him in. Dun, 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 dun. But you can cancel out. Yeah, but when you cancel out, it's not the same function. Canceling out is a new function whose hole is filled. He has a hole. He does not exist at 2. So therefore, no, he's not continuous at 2. Oh, lo siento, it's 2. B. I was too excited about talking about why 1 was wrong than circling the right answer. Oh, you do it too, and I don't even know what your experience is. Okay, so, love you all. Coming back. Boop. What else? Any more odds? Any more odds of multiple choice? Okay, evens real fast. Which ones did I skip over? Number 10 was one. 8 and 10? Okay, let's do those 2 first, and then we'll come back. Ah! I love 8. Why? I told you to watch out for who? E. And what do we have in number 8? An E. E. You guys know what I'm talking about? Little circle, big circle. Little circle, big circle. W, W, E. Anyway. You guys don't know that one? I forgot my half circle. I forgot his ears. I know. Okay. If you guys have ever done the pig, but there's like an E for his tail. Stop, not important. Calculus. Where are we headed? Infinity and beyond. But where's the x? The x is there and the x is there. That's it. That's it. Kind of hard to see, so let me write it big. Limit as x approaches infinity of 1 plus e to the 1/2 plus 1. What's the only place infinity is going into? Right there. So if I have an x and if I have him going right there, then, wait. Is that all I'm looking at? So 1 over bigger numbers. Who wins? The bottom. And if the bottom wins, what's this piece going to? Well, what's he doing? I don't know. He's fine. But what's he doing? So if he goes to 0, then don't I still have this and this and this and this? I still have all kinds of stuff. So what's my final answer? Letter D, of course. Okay, number 10. Number 10 was not a question that period 1 asked. Interesting. What's going on? Where am I headed to? Infinity and beyond. What am I looking at? We can call it stuff now. We can call it the end behavior model. We're looking at those two dudes. Aren't their degrees tied? So can't I say the limit of this is going to be 5 over negative k, or negative 5 over k? And if that's the limit, what do I have to set them equal to? Can't we do some like cross-multiplying action? It's okay. I'll end up with 10 equals negative k, k equals negative 10. I think. Looking good? What else do we got? 14. Oh, 14. Ooh, I like it. Yep, period 1 didn't like that either. Some of you see the little from above and you freak out. Pause. What do we always do when we have limit approaching a constant? Always. First, plug it in. Oh, it's 0 over 0. L'Hôpital's no. First of all, technically, if this was an FRQ, we couldn't write equals over 0 anything, because the limit can still equal a value. The function equals DNE, but the limit does not. Something that we're going to have to be careful of when doing limits on FRQs as the AP gets closer. But I can say, I'm supposed to be looking at the limit of the top, and I'm supposed to be looking at the limit of the bottom. This will save me from saying the limit equals a DNE and then the next second saying it equals a number. Once again, in multiple choice, it doesn't really matter, but FRQs, it does. The bottom is 0. What does an ln do as you go towards 0 from above? Oh, not 0. 0. Number over 0, and not just any number, a negative infinity number. Dang, it's like infinite. Number over 0 is infinite anyway, and a negative infinity over 0, it's super infinite, but not just any infinite. What sign do we have? Dun, 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 dun. Anything else multiple choice? Going once. Going twice. . Sold. FRQs. Oh, sorry, I just passed one, didn't I? Lainey, you've been waiting for this. What do you want to see, kid? 1B? Okay, let's start with 1B and then go to 1C. Both of them have the first or the beginning information. There. Describe all values of A and B such that H is a continuous function over the interval 1 to infinity. So 1 starting there and going forever. I don't have to worry about the other side of 1. Okay, fine. What's it say? What do we know about, why am I awkwardly turning? Continuous? Should you have somewhere in a colored pen with highlighting all over the place something to do with piecewise functions, limits, continuity, differentiability? Yes. How do I make a piecewise function continuous? The pieces have to meet. Where? At the separator, of course. And who's the separator? Oh, so if I come below 2, and if I come above 2, what has to be true? They must meet. But what piece am I plugging into when coming from, Lo siento, coming from below? Do you realize I could have just lost a point on an FRQ if I wrote F and his name is H? Yeah, I'm serious. You gotta be right, not wrong. Okay, what piece am I plugging to for below? Because the top is the lower than 2. Okay, 2 minus 1 plus 3. Coming from above, it's the above piece, of course. So then 2 squared is 4a minus 2b. What has to be true? These two must meet, agree, equal. But wait a minute. Did they say what does a equal and what does b equal? No, they said describe. Describe. 2 minus 1 is 1. 1 plus 3 is 4. Describe. A better way of describing is usually to get one variable by itself and say, oh, all values of A is such that it's related to B, or all values of B is such that it's related to A. As far as I've been able to see, they always get one variable by itself. This also happens in slope field questions when they say something like describe when all the slopes are positive, negative, etc. And you're like, oh, well, And you make some inequality, some equation. Could you put that? I think you'd be okay. I think you would, but just because I've seen a lot of AP FRQs and they always get a variable by itself, we're going to get a variable by itself. They don't say which one to get by itself, they just say describe, so I don't care. Let's get A by itself. So therefore, 2B plus 4 all over 4. Got him, coach. But what does C do? C goes one step further and says, you know what, not just continuous, but also, and they don't say describe, they say find. Well, what's extra about differentiable that lets us not just describe an equation, but actually solve? We just talked about how to make it continuous. How do you make it differentiable? Don't we look at the derivative instead? Who's the derivative of this guy? Oh, you know. H prime of x is equal to. Isn't the absolute value of u's derivative the absolute value of u all over u times u prime, which is 1, plus 0? The derivative of this guy would be 2ax minus b for x greater than 2. And x equals 2 is still out there because I haven't made it match yet. And derivatives don't exist if they don't agree. Sharp points, the derivatives don't exist. So how do we make this one work? We say, well, the limit from below and above have to meet up for the derivative. So coming from below, the derivative. Coming from above, the derivative. Some of you might want to, in a colored pen, somewhere on When You See You Think or somewhere in your cheat sheets, whenever you see differentiable with piecewise functions, the derivative has to be continuous as well. The original function has to be continuous and the derivative has to be continuous. So now we plug in 2 minus 1 is 1. Well, here. And down here, 2 times a times 2 would be 4a minus b. And if these two need to match, don't I have another equation now? That'd be 1. What do we do if we have 2 equations that must be true? Set them equal to each other, or solve for b and substitute, or system of equations with elimination? I don't know. You guys know how to solve with algebra. Don't you get me my a and get me my b. Whew! Tomorrow, what you doing? LTF number? Bringing the odds and maybe even the evens. What needs to be happening by 5 p.m. tonight? Submit number 1. Bye, cool kids. I'll see you later.